Hey everybody, I'm Jeremiah and today I'm going to show you how to graph a jellyfish using parametric equations. This is a little skill I picked up being bored in math class playing around on a TI-84, so you can definitely do this on a graphing calculator too. And I'll show you how that works at the end. But if you don't have a graphing calculator, don't worry because you can do it online too. Just go to Google and type in parametric graphing calculator, and I like using this first one that pops up from Desmos. Just a little review in case you haven't seen parametric functions in a while. All it means is having functions of x and y both in terms of t, where the x function moves along the x-axis and the y function moves along the y-axis as t moves along some interval like 0 to 2 or negative 5 to 5, any interval you want it to be. So the first general equation we need to know is the parametric equation of a line, which is x of t is equal to a plus bt, and y of t is equal to c plus dt. So if t's interval begins at 0, then the point AC will be the starting point of the line, and it will have a slope of d over b, which is rise over run. The other general parametric equation we need is the one for a circle, which is x of t is equal to r times cosine of t, and y of t is equal to r times sine of t, where r is the radius of the circle. So the way this software works, we don't actually need the x of t equals or the y of t equals. This left coordinate tells us it's a function for the x values anyway, because we know a regular coordinate pair is in the form of x comma y to begin with. The last thing we need before we can get started is the unit circle from trigonometry, mostly because of how it relates to the circle equation. Having t go from 0 to 2 pi makes one full lap around the unit circle and will graph a full circle. If I want to graph a half circle though, then I'll multiply t by a half. So the interval goes from 0 to pi and I get the upper half of the unit circle. It's the same idea if I want a quarter circle or 3/4 of a circle or whatever. I just multiply t by that value since t goes from 0 to 2 pi. The first thing you want to do is go over to the top right hand corner, click on the little wrench, and change your window settings so the x interval is on -10 to 10 and the y interval is on -6 to 5. Alright, now we're ready to start graphing our jellyfish. So the first function we're going to enter is the one that will make a half circle of radius 4, and that'll be the head of the jellyfish. So that'll be x is equal to 4 times the cosine of 0.5t, and y is equal to 4 times sine of 0.5t. Where t is on the interval 0 to 2 pi for all of these. Next will be the bottom part of the head of the jellyfish, and this is kind of a more complicated function, because we need to start, instead of on the far right, over on the left, shift it a little. So our x function will be x equals 5 times cosine of 0.7t plus pi minus pi over 5. And so what that does is the plus pi moves it over to the left side, and then the minus pi over 5 just makes it go up a little bit. And you'll see we'll have the same thing for the sine function, which will multiply by 0.5, so it's a long and skinny circle, part of circle. And then lastly, we have the 4 stingers, which are all going to be sort of the same kind of format, where it's like a line going down, but then in the x function we include a sine function that will make it wave around like a sine wave does. And so the functions for that will be x is equal to -3 plus 0.8 sine of 1.4t, and y is equal to -0.4 minus 0.7t. The -3 and -0.4 are our starting point for the line, remember? And the minus 0.7t in the y function will make it go down, and the 0.8 sine of 1.4t will give us that wiggling that we want. You can get pretty creative with the different values for the functions on the stingers if you want. The number that you multiply the sine function by will be how big the waves are, and the number inside the sine function that you multiply t by is how many waves you have. And so it's really just, aesthetics, how much wave and how big of waves you want your jellyfish stingers. So I honestly never use the same ones twice. But the ones I use here are, for the next one, x is equal to -1 minus 0.8 sine of 1.6t, and y is equal to -0.5 minus 0.9t. The next stinger I used 1 plus 0.7 sine of 2t, and y is equal to -0.5 minus 0.8 times t. And for the last stinger I used 3 plus 0.7 times sine of 1.5t, and y is equal to -0.4 minus 0.7t. And at the end of all that, you've got yourself a jellyfish.